should hopefully be your last video. I want you to take example 6 and do what we did on example 5. Find the vertical asymptotes by setting the denominator equal to 0. Horizontal asymptotes by comparing those leading terms and looking at the 3 different cases it could be. The x-intercept by setting the numerator equal to 0 and solving. Y-intercept by plugging in 0 for x. So pause the video, do all 3 of those, and then come back and check, but use this time wisely to actually pause it and actually work it to see if you know how to do it. Okay, so over here in orange, I set my denominator equal to 0, got x plus 5, so I got x equals negative 5 for my vertical asymptote. I got that twice, so it should have a multiplicity of 2. You don't have to write that, but that helps you on the graphing instead of plugging in points. Compared my leading terms for my horizontal asymptote. Bigger is on bottom, so y equals 0. I wrote this earlier up top, not check that this is the correct way according to the theorem. If the bigger is on top, there's no asymptote. Bigger on bottom, y equals 0. Your earlier notes, I might have swapped that, so please check that. I don't have it to see what I put. X-intercept, numerator equal to 0, solved. I got negative 21 over 5. I converted to a decimal because that's going to be easier for graphing. And then y-intercept, plug in 0, solved 21 over 25. It's a lot of work, but I mean, really, it's only just a few lines, and most of you probably don't have to show all of that. So now I'm going to pause it. I'm going to graph those 4 things, and I want you to do the same. Okay, so I graphed my vertical asymptote, horizontal asymptote, and both of my intercepts. Okay, so now I just need to put the graph together. Again, you can test points if you want, but I can see it's going from here to here, and it's going to go along that asymptote. It wouldn't be quite as sharp as that, but something like this. Right, and then I know this is a asymptote, and up here we had the multiplicity of 2, so it's going to do the same thing on both sides. Because it went down here, it has to go down here because it's a multiplicity of 2. You know, even multiplicity means they go the same way. That works the same on asymptotes. So this goes down as well. Okay, then I push this off and I know it approaches this asymptote, so it's going down. So what happens is, as it's approaching negative infinity, it's going to 0, and as it's approaching infinity, it's going to 0 over here. And then at the asymptote, they're both going to infinity. What happens is it hits this 0 and then kind of comes towards here and goes this way. And that's the best picture you can get from this information. If you did test points, you would see that somewhere in here it actually goes way up and then comes back down. And you would have to test points to get that. Just based off the 4 things we graph, you'll get this, which is still a great picture. It shows the behavior at the asymptotes and the end behavior, which is what we're wanting to show. Okay, now example 7, I'm not going to write the notes for you. I want you to find all 4 of those things on your own. Pause it and do it all by yourself, please. See what you know, and then come back and check it. Okay, so I found my vertical asymptote by setting my denominator equal to 0, factored, solved, got 2. Same degree for my horizontal asymptote and my leading terms, so I compare the coefficients. That's a 1 over 2 for my horizontal asymptote. For my x-intercept, set it equal to 0, the numerator equal to 0, factored, solved. For my y-intercept, plugged in 0 for x and solved and got negative 4. Be careful that you do know what goes with what, because like x equals 0 and x equals 4, don't get them confused. X equals 0 is a vertical asymptote, x equals 4 is an x-intercept. I want you to pause, graph these 4 things, and then connect to find your rational graph. Okay. I just saw a mistake, I'm sorry. Hopefully you called this when you worked it on your own. I typed this in, I got negative 4 over 0. And negative 4 over 0 is undefined, and so the answer here is that there's no y-intercept. I apologize for just catching that. Like I said, hopefully you did. Now graph these and connect it. Okay guys, so sorry, I called another mistake. Again, if I had you in class, you would catch it for me. I'm sorry, this is what I get for working, I guess, on a Saturday morning. When I factored out a 2 here, well, what happened is I graphed mine, and I realized I only have one intercept, except this other intercept's on this asymptote right here, right? And so that's really weird. So I looked and factored a 2 out, and that should have left me with x plus 2, which would leave me with a negative 2 as my vertical asymptote. Again, hopefully you had that fixed, and I apologize for that. So I'm going to fix this in graph. Okay. So I have 2 zeros, and I have a 0 here, and I know it's not going to go up to the asymptote. So I know it's going to look something like this, and it's going to approach negative infinity. And then I know this had a 1, like it had a power of 1, so it was an odd multiplicity. And so that means it's going to be going up to infinity on the other one. I know it has to cross this intercept, and so then it's going to go to negative infinity. Something like that. You have a little cubic function looking there. And then I have, this is still, again, a multiplicity of 1. And so I know it goes in opposite directions. And so since this goes to negative infinity, this up here goes to infinity. And I have this asymptote. See how it crossed the asymptote here? Remember we talked about it can cross the asymptote, but ultimately it's not going to. So at the very far left, it's not going to cross that asymptote, and at the very far right. And here's that. Okay, so we have one more new thing to talk about, and that's a slant asymptote. And so a slant asymptote is literally going to be a slant. So it might look something like this, and you have a graph that kind of looks like that, and a graph that kind of looks like that, like it has a slant to it. And how you find the slant asymptote is it only happens when the degree of the numerator is 1 more than the degree of the denominator. So like if I have x cubed over x squared, or x to the 4th over x third, it will not happen because that's 2 degrees difference. Okay, so when I have 1 degree different, I can have a slant asymptote. This is when you have a slant asymptote is when, of course, the numerator is bigger than the denominator, which gives you no horizontal asymptote. And so when you have no horizontal asymptote, there's a chance you'll have a slant. You won't have both. Okay, so this means no horizontal asymptote. If it's 1 degree more, it means you could have a slant. So we're going to, it says use the division algorithm. We're going to divide to see. Another name for slant asymptote is oblique asymptote. So know both of those names, and we're going to do that here, but we're going to start. What I need to do is find both of the asymptote, the horizontal and vertical, find the x-intercepts and y-intercepts, and then start back. This is the last problem, so do this for me so that you know what you're doing, and check yourself, and hopefully I won't make any mistakes this time. Okay, so if I'm a vertical asymptote, there's no horizontal asymptote because the numerator has a bigger power, higher power. If I'm an x-intercept, I'm a y-intercept. There's no horizontal asymptote, which means there could be a slant asymptote. I checked, and there's a slant asymptote if the numerator is 1 degree higher than the denominator, which there is. So I'm going to check for, or I'm going to find the slant asymptote. And so how we find the slant asymptote is by dividing. And so here we're gonna, actually you can use long division or synthetic. Your book does long division, we need to divide this. So x minus 3 into that. So I'm going to pause and do, I'm going to do synthetic division. You can do long, and then come back and check your answer. Okay, so synthetically divided 3 in, you could have done long division. What matters for our slant isotope is our quotient. Now, this is not a factor, right? It wasn't a 0, so it's not going to go in whole, and that's okay. It's going to have a remainder, and that's fine, but it's actually only the quotient that matters. So I get this is my quotient, and I rewrote that, and this is my slant asymptote. So remember we said it's going to be a slanted line. You should have a line here, so y equals mx plus b. So it has a slope of 1 and an intercept of -1. The slant asymptote does. So I'm going to do my graph, and I'm going to start by graphing the slant asymptote. And so the slant asymptote has an intercept of -1, and then it goes up 1 over 1 over 1. And that's what the slant asymptote looks like. I'm going to graph my other, so my vertical asymptote is at x equals 3. No horizontal asymptote. Stop you up here. And I have my x-intercept at 5 and negative 1. And then I have my y-intercept at 5/3, which is 1.3 repeating, which looks something like that. Okay, well, if I'm connecting my graph, I know this one goes here, and I know it's going to go along these asymptotes. So I know it's going to look something like that. And then you know it's down here. And same thing, it's going to go along my asymptotes. And so it'll kind of look something like that. It'll probably look more, it's not much better, but a little something like that. And there's your last one. So in order to find your slant asymptote, it's only when the numerator is 1 power higher than the denominator. And to find the slant asymptote, you do either synthetic or long, and your quotient is what you're looking at, and then you graph that like a normal line. Okay, that's section 6. Now I need you to do the 5 and 6 problems for homework. Email me if you have any questions tomorrow when I come back on Tuesday. I'll check your section 4, 5, and 6 homeworks. I'll check all of those. So check those, check them with the key, make sure they're right. If you have a lot of questions, come see me before school or email me.